Yes, hi.
Yeah, yeah. He's a graduate research assistant from DataSearch, and he's also a graduate from University of Morato with a degree in computer science and engineering, specializing in computer science and engineering. He has worked on different areas. Currently, he's also working at an actor. And I will let Sudeep talk about how we can use data science to solve the problem of transport in Sri Lanka specifically. Yeah, Sudeep, please continue your presentation.
Yeah, thank you, Dr. Shan. I hope that you can see my screen. Can someone verify it?
Yes, we can see.
Okay. Okay. Hi all. My name is Sudeepa Nadeeshan, and I'm working on transport-related project in DataSearch. My project title is Travel Behavior Analytics using GPS product data for public transportation services. So, as you all know, like traffic is a growing problem that we are. 1 second. Yes. Sorry. Yeah. It's a growing problem that you're facing every day. So, as a solution, that experts are suggesting to use public transportation to solve this problem. It has many environmental and cost benefits. As you can see in the picture, a picture can say 1,000 words. So, if we are to use public transportation, we can use many common resources in the most effective way. And in Sri Lanka also, we are talking about light railway transit and bus prior lane these days. But actually, if you take the reality, uh, uh, we as passengers are not interested in public transportation. Actually, the problem is Sri Lankan transport system has not been able to properly address the customer satisfaction. So we have problem with the comfortness, the level of service that we get from public transportation, and the reliability. Especially, we don't know when would the next bus come. That's a problem that we are facing in real life. So we can add smart transportation system to avoid this problem using technology. So let's see. So as I mentioned, there are many features that we can develop. We can give to the passengers using a smart transport system. So as an example, traffic management, traveler information system, parking management, etc. And here we are focusing on travel information system, especially for research. We are focusing on providing bus arrival time information to the passengers. So let me explain how the smart transportation system work. This can be shown in a four-step process. First, we are collecting data from multiple sources. Then we have to build an infrastructure to transmit the data so that we can analyze the received data and derive useful information out of that. So then this derived information then can be transmitted to end users. So that's the process that we have to follow. So for our research at the moment, we are more focused on data analysis, how we can do the data analysis on the collected data. As I previously mentioned, data collection is the fundamental step in building a smart transparent system. We collected two types of data here. First one is GPS data. We were able to access the NTC, National Transportation Commission, GPS data for route number 1, that is which goes from Kandy to Colombo, and these were collected from intercity buses. So that made our problem specific, as these buses have a very low frequency compared to the intracity buses. So the following drawing shows the relevant details about the data that we have. And the other data set that we used is weather data. We might have experience how the weather can impact on travel time in real life. So actually we try to find the local source to get the access the weather data. For we couldn't access the stations nearby, so we extracted the weather data from worldweatheronline.com for the following cities, and the following features were able to extract from the weather data. And so now we have collected, transmitted, and now we are going to analyze the GPS data. So one of the main problems that we were facing, that GPS data have spread all over the area. So if you see the highlighted blue line near the red drawing that I just drawn shows the actual route from Colombo to Kandy. So here the problem is, here we are using the OBD port of the bus to collect data. So the device is collecting data whenever the engine is in start state. So that has brought many anomalies to the data, because whenever the engine is started, we are collecting data. So these are the so let me quickly go through the some of the anomalies in data. First one is having multiple possible routes, as you can see in image A, to travel when it comes to last link. That is, when it comes to the beginning of the journey and end of the journey. So also we are recording some of the irrelevant data, like drivers home to bus station and bus stations to home data. And also there can be some private journeys, as you can see in image C. and and also there is the problem of having bypasses in the middle. So all this problem, one of the reason is, like, we are not closely monitoring the drivers in our transportation infrastructure. We are not closely monitoring, but this is the data in real world, so we have to pre-process them. So as I mentioned, now we have identified the problems, and so let me explain how we get rid of them. We used following two main technologies to uh, filter or clean the GPS data. Those The technique that we used is map matching and geofencing. These are the main techniques that we use. Map matching is a process where you identify the road segments that the bus actually travel using the GPS observations you have. GPS data may not precisely provide the location of the vehicle, as GPS technology has its own limitations. But we can aid map matching process to uh, identify the relevant road segment. Let's say road, as you can see in image R1, R2, 3, the vehicle actually travel using the observation points like O1, O2, O3, etc. etc. So we use geofencing to identify the journeys out of the GPS uh, data that we collect. Here, journey can be defined as set of GPS tracers that represent the trip uh, from the starting bus station to ending bus station. So we use geofencing to segment these journeys out of the GPS records that we are getting. And so now we have identified the relevant GPS points for our analysis, and our aim is to identify the travel time out of them. So for that, we have to perform segmentation on GPS data. There are three main widely used segmentation methods that is used for researchers. Those are bus stop based segmentation and section based segmentation, and also there is junction based segmentation, which is the one that we have used. So we selected junction-based segmentation as these intercity buses are not supposed to stop at every bus stop in the road. So we can't use bus stop-based segmentation if you are looking at the problem. Also, the section-based, if you take section-based method, this could lose the sensitivity because usually a segment is has a length of like several kilometers. So after segmentation, we calculate the travel time of each segment as follows. Uh, as in the given diagram, using interpolation. So now we have calculated the travel times also. So let's move into travel time prediction. When it comes to travel time prediction, we can predict two different travel times. Those are direct travel time prediction and average travel time prediction. In direct travel time prediction, we are predicting the travel time for single bus. That can be based on the distance, as you can see in number one, or based on the segments, as per the number two diagrams that you can see. So distance-based travel time prediction, that can be considered as one of the most primary way of predicting the travel time. Uh, let's move into the journey-based travel time. So in journey travel time prediction, we are predicting the travel time of the upcoming segments based on the travel times of the previous segments. Here we first record the travel times like T1 of segment 1 and T2 of segment 2, and then we try to predict the travel times T3 and T4. we can also predict the average travel time of the segments, as you can see in the number 3. This is comparable less effective in our specific case, because our specific case is we are trying to predict the travel time for low frequent buses. That is predict. So here the actual problem is what is the time window that we are going to select, and that's one of the problem that we are facing when you are using link average travel time prediction. So this is a summarized result that we got so far. We used mean absolute error function to evaluate our results for averaging. Uh, so yes, for yes, we had to use 1 hour time window as our minimum time window. As I mentioned, this is travel time predicting for low frequent buses. So with this comparison between average and journey based prediction, we can see that the error is increasing rapidly with the time step when it comes to the average travel time prediction. So we also compare these two models with historical averaging, as you can see here. And so I think one slide has come in front of the other. So this is actually the model that we use, that is LSTM based model. So this is LSTM is kind of an improved version of neural network. So we specifically adapt bidirectional LSTM, which has been heavily used for language modeling, but it has shown some better performance in some other domains like stock price prediction and traffic prediction. So the following model architecture, auto-encode architecture, was used to develop our model. And as I previously mentioned, we can decide several variables as the one that we are going to predict, that is based on the journey travel time or the average time. So we developed models for that, and I'm sorry that this is the results that we got as I previously shown. And so that's the progress of our current research work, and we have published one research paper on an improvement that we did on HMM-based map matching algorithm, and that has been presented in Core 2020. So I think that's the end of my presentation, and thank you very much. If you guys have any question, just ask.
Okay, thank you, Sudeep. Any questions? Yeah, I'll leave you to ask questions on the Q&A. We'll move on to the last presentation for the day.